Okay, it is an important concept with regard to specifically to the design of relations. Okay, you have already covered how to design a relation, how to do an ER or ER diagram. Then you move from ER or ER diagram to create relation. Now, let's say you do have in front of you relations. When we talk about relations, we mean tables. Okay, those tables with their corresponding attributes. Okay, which consist of rows of information. And now we can have maybe, for instance, for the same design or for the same database, we might have different design. We mean when we talk about we might have different design, it is related to how many relations you have created for such database. And for instance, and how many attributes you have inserted during your design to be part of your relation or your relations. And we might have different design for the same database. Now, which design is better than another? Now, which design is good and which design is bad? So we need to find out how we can evaluate such design. And when we talk about evaluating the design, okay, which is related to the goodness of a relation schema. This is what I mean by design. Okay, and you know what is the relation schema? Is the concept, the design of the relation. What are the different parts that are that makes your relation or your table? And in terms of the relation, how the design is done, okay, what you can do, we can have of a logical or conceptual level. We can do it at the conceptual level, which means when you do have a user, and user is presented with a relation, well, it is presented with the design of a relation, a schema or a relation schema, how that user can interpret the meaning of the attributes that are part of that relation. How easy, we mean by how we interpret, how easy for that user to interpret the different types of attributes that are part of the relation schema. And we can also, this is with regard to testing the goodness, which is we can test it at the level of logical or conceptual level, whether it is good or not. For instance, if a user can interpret easily the attributes that are part of the relation schema, we can say, we can have at least, let's say, a light that, or a sign that the design of our schema is good, because it is easy for a user to understand the meaning. We're going to see later an example. Or we can test the goodness of a relation schema based on a physical storage or implementation level. And this is not easy for us to do it, because you need to, for instance, to go to the physical level and to look at the indexing and all the stuff that are related to the physical level, and check whether the design or whether the relation schema is good or not. But at our level, which is the easiest part, is to test the logical or conceptual level, whether it is good or not, because we can see exactly what are the different relations, the schema, the relation schema, and we can at least give an impression or to give an idea or a sign whether we can say this is a good relation schema, this is a not good relation schema, this is a medium, and so on. Okay, guys? So this is the idea about introduction to the idea about when we talk about the goodness of a relation schema, because when we talk about normalization, we're going to see later the normalization, which is a process. It's like an algorithm or a process that will let you make your relation schema good. Any questions, Shabab? That I have heard something? Yes.
Yeah, this is, Doctor, the first criteria that we can compare the best design for our case, right?
Yes, because when it comes to do relation schema, the structure of your database, you will say, for instance, my database is made up of 5 tables, so 5 relations, and relation 1 has this and this and this attribute, relation 2 has this and this and this and this attribute. So you can at least have an idea whether the design you have done is good or not. And there is a procedure, we're going to see later, there is a procedure, there are steps that will help you to say whether this is good or not. When I see your relation schema, I can tell you, I can just do some tests and verify whether it complies to, let's say, at which level. Because when we talk about the level of the relation schema, okay, or the goodness of your relation schema, we can have at 3 levels, for instance. I can tell you your schema or your relation schema has achieved a goodness of level 1. If I am going to grade your relation schema, I will tell you your relation schema is it's like a marks. Okay, let's say maximum marks is 3, for instance. I will tell you your relation schema has a mark 1. Another schema, another design may be given mark 2. Okay, another design maybe will be given mark 3, which is the highest marks. That means it is, and I can say and I can testify that this is a good relation schema because it achieves highest mark. And this is what we are going to do in this chapter, to go to follow some steps and make sure that whenever you do a schema or relation schema, you can say that this is I am sure based on this criteria or based on this procedure, I can tell you that my relation schema is good and it does or it did have achieved a good relation. Okay, Shabab?
Doctor?
Yes?
Doctor, let's say for our course project, if we turned our ER to a relation schema and then we evaluated and it turned not so good.
You have to make it good. You have to go through some levels of goodness. And you're going to see later. You will see later. It is easy. It's not a big deal. Okay. Because whatever you do, as we mentioned at the beginning of this course, when you do the design, it is considered like a draft before you go to the implementation. So you need to do that, because if you don't do that, that means you will find and you will face many problems when you do implementation. When you go to the computer stuff or computer step and you want to implement what you have designed, you will find, and maybe when you populate, when you insert data later, when you do, you will find many anomalies because you did have a bad design. That's why we need to avoid. Okay, we need to avoid such in future, such anomalies to happen when we insert. We're going to see some example later, inshallah. Okay, Shabab. Now, in terms of designing, okay, now how you are going to do a design, or how you are going to create relation schema, there are 2 approaches. The first approach is bottom up or a top down. Okay, when we talk about the bottom up, that means in reality, when we talk about, let's say, when we talk about relation schema, okay, whenever we talk about relation schema, that means you do have some, just let me open a Jamboard. Okay, now for instance, when you talk about relation schema, okay, we are talking about a relation. Okay, let's say this is a relation. We have already covered it in previous chapters. Okay, you do have a relation and you do have the attributes that are related to the relation. Okay, this is what we mean by relation schema. Okay, let's consider as a relation, for instance, student. Let's call it relation student or student. Okay, and you will have some attribute. Okay, I can have student ID, for instance. I can have student name, CD name, for instance. I can have student mobile phone, and you can imagine any information that is related to your student. For instance, a mobile. Okay, can have address, course, for instance, because this guy is taking, maybe. Okay, and you can have many other information. So this is what we mean by a relation or creating a student relation. Now, how did we, or on what basis, this is the main question, which is related to the relation schema. On what basis I have decided that the relation student should have this and this and this and this and this attribute? Any idea, Shabab?
The AR diagram.
Business
Now,
requirement or AR diagram.
even the AR diagram, when you are saying AR diagram, when you say AR diagram, you have already defined, okay? You did have your relation and you already defined those attributes. Now, how did you decide that these attributes are part of my student entity?
From the
This is my
requirement.
question.
Business requirement. Business requirement.
Okay, from the business requirement. Now, when you are talking from business requirement, that means what you are going to do. For example, let's say this relation student is part of university database. So how did you ended having or deciding or collecting, let's say collecting student ID, name, mobile address, course? Yes, Shabab?
How can I collect them, Doctor, you mean?
Yeah, on what basis you decided that I will have an attribute that is called student ID?
Based on business
From customers.
From customers. Okay, you went to the university, you did some survey, you asked customers, you asked stakeholders, and you decided, okay, let's say you decided that among, I do have here, for instance, let's say a bag of attributes. Let's consider these are attributes. You collected all these attributes or these attributes. Okay, so these are the attributes that you have collected. Okay, and there are many attributes. Okay, Shabab, there are many attributes, which are now these attributes can be of different location, with different meaning, with different, let's say, we call it semantic, which is the meaning of the attributes. Now, among those attributes, okay, let's say we do have many attributes, okay, with different meanings. For instance, I will tell you, for instance, this whole bag contains attributes that are related. For instance, I do have student name, I do have course ID, I do have department ID, I do have salary, I do have prerequisite, I do have grade, I do have transcript, okay, which are now represented with these different colors.
So, Doctor, this is the mini world or the universal?
This is what you collected. This is what you have collected. Okay, let's collected attributes from PSU. Okay. So after asking people, after going through some survey and stuff, and you decided, you collected, these are the attributes that I have collected. Now, the next step is what? Don't forget that we are going towards creating relations. Okay, so you do have now a mixture of attributes. What you will do?
Assign them to entities.
Yes.
Assign them to entities.
Assign them to entities. How you are going to do that? This is the idea. This is the idea about the goodness of the relations. Let's say, okay, let's give you an example here. For instance, which color we haven't used? Okay, I didn't use this one. Now, let's say I have decided to create this relation. Okay, what I will put inside, I will go here and collect some attributes. I will put here an attribute with the red color. I will put another attribute with a blue color. Okay, and I will put an attribute also. Okay, I will put another with a blue color. Knowing that this different, let's say, attribute, okay, belongs to have different meanings. Okay, now let's consider that, for instance, this red one is about a course, an attribute about the course, maybe course name, maybe course code, whatever. Okay, and this attribute, for instance, okay, is about, let's say, employee. Okay, an employee. Okay, and the same thing, this one is also about the employee. Okay, do you think it is normal now? This is my relation. This is what I have created. This is my, I call it relation A. This is the schema of my relation. I just created the relation, and I put an information about the course and information about employee.
No, I think it shouldn't be like that. It should be
Why?
separate.
They should be
Relation of
separate.
employee.
Okay, good. That means,
Yeah, while
we
we having two
we should-
employees.
yes, we should not combine, we should not mix up information, or within my relation, information about employee with information about course, unless they are related. So basically now, the approach that I was telling you, which is bottom up, okay, we said that we can have bottom up approach, okay, which is difficult to do. This is what we did in order to, for instance, to verify that all these attributes are related. I will do a pair comparison. I will compare this one with this one. If they are related, I will put them together. Then I will compare this one with this one. If they are not related, that means I don't have a problem here. I should not include this one, or I should not include this one. And I will do a comparison or para between two attributes, between this one and this one. That means here, if you do have 100 attributes, and to decide whether which one should be included in relation A, okay, what I will do a comparison between each pair of attribute, which is not practical. This is what is meant by a bottom approach. Okay, that means you need to I will compare this, for instance, this attribute with every attribute that exists here. Okay, and if they are related, I will decide to put them together. Then I will move on to the next one to see and compare it with others, and so on. So it takes time, and it is not easy, and it will not lead to a good or to an appropriate relation schema. This is what is meant by a bottom-up approach. That means you start by collecting attributes, okay? Then you do comparison, you do pair comparison between each pair, between each two attribute, and see whether they can be within the same relation, okay? Whether they can be within the same relation, in order to verify whether they can be part of the same relation schema. The other approach, which is the top-down approach. Top-down approach is the more practical. What is more practical? That means what I will go, for instance, I will look at the report, for instance. Okay, let's say you do have a transcript. You have a transcript, student transcript. Okay, Usually, what do you have in the transcript? What are the information that will be included in the transcript, Shabab?
Courses and the grade for each course. And the
Courses. Yes, great. What else?
also the number of hours of each course.
Student
Credit
name.
hours.
Student names. Okay. Student ID. Yes.
Credit
What?
hours.
Total hours. Yes.
GPA.
GPA. Okay, let's finish with this one only. Okay. Now, from the transcript, okay, if you can see here, we have courses, grade, total, and GPA, total hours. Now, if I am going to create a relation that I will call, let's say, transcript relation, okay, it is easy for me now. Okay, from that transcript paper, for instance, I will just include, okay, for instance, I will put in my relation, I will put a course, I will put here transcript or grades, I will put names, and it is easy because I have what I did here. I have just collected, I did have such information. It is already gathered in where? In a piece of paper or in a transcript, and they are related. The guys, the designers who did that student transcript decided that the transcript will have this and this and this and this information, and it is already there now. So it is easy for me now to create. I will go to student transcript. I will go, for instance, course description. Okay, and the course description has many information. I will just go there and extract the information that is contained within the report or within a file or whatever the source you are taking your information, and you decide that this information should be part of this relation, which is now I can say that I do have relation, for instance, transcript. Okay, so this idea or this in this way, it is better, it is easy. Okay, it saves you time, and you are sure that what you are going to include, okay, within your relation is really needed to be there. Okay, and this is what we call a top-down approach. Top, you start from a file, like you start from a report or whatever, and you just extract the information that is there. Okay, even if you do have a report, maybe I can have a report, and the report will contain many sections, like chapters, for instance. You have many sections: student transcript section, courses sections, prerequisite sections, and you can extract. You can go to that section, so to that report, and extract and decide that I will create relations based on the sections that are appearing within my report. This is what is known as a top-down approach. Clear, Shabab?
Yes.
Okay. So these are in terms when it comes to the design. When it comes to the design, as we mentioned, we can have those two approaches, bottom-up or top-down. Now, in terms of some guidelines for you, okay, before we start talking about the process of normalization, okay, which are straightforward steps, we can have at least some guidelines. Okay, it's like you do have a first sight. You look at your design, okay, and you might decide. Okay, you might say it is a good or bad design based on some guidelines. Okay, which helps you to measure the quality of your relation schema. Okay, the first thing is to make sure that attribute semantics are clear. When we talk about semantics, what is semantics, Shabab?
The meaning.
The meaning, okay? When here, the first thing, when I give you, for instance, I will tell you, this is my relation schema. And just by looking at the attribute, you can, as we mentioned, you can automatically say that the attributes semantic are clear. That means the meaning that will result from the interpretation of those attribute value in tuple, which means it is easy to explain the semantic of a relation. Let's pick up an example. Okay, when you do have, for instance, I will just present you with employee relation and department. What can you say about the E name?
Employee name.
Employee name, SSN.
Social Security.
Social Security number. What about this one?
Birth date.
Birth date, yes.
Address.
I will say this is the address, okay? And I can say, for instance, what I can say. I can tell you, for instance, each tuple, okay, in my relation represent an employee. You know, you have already covered tuple in the previous chapter, Shabab, tuple. Yes, guys?
Are the rows?
Yes, they're rows. Yeah, we have already talked about it, okay? We can say in our relation, each tuple represents an employee, because based on this one, this is an employee. That means each line or each row represent an employee. And those employee, that employee has a value, which is the E name, which represent the employee name, okay? It does have social security, it does have a birth date, it does have an address, okay? And it does have a number of the department that the employee works for, which is the D number. And I can say also that D number is a foreign key. It is a foreign key that will that will represent a relationship between my employee relation and my department. Okay, I do have a D number, foreign key to my primary key in the department, which is the D number. So it is easy for me to explain the meaning and the semantics of the attribute. If I go to the department, I will say also the semantic of the department. Okay, it is straightforward. Each department tuple represents a department entity. Okay, and if you go, for instance, to project, you can say each project entity, each tuple in my project relation represent a project with project name, project number, the location, and in which department. And that department number, it is a foreign key to the department location. Okay, and so on. So you can see here we do have, quickly we interpreted the meaning of each attribute or each tuple within the relation. This is an example of something that is simple, and we can say that because we managed, okay, to automatically interpret the different types of attributes within my each relation, and we also specify the relationship between each relation, we can say, okay, that we do have, let's say, we are applying, or we are abiding to this guideline, which is a clear semantic of a relation. Okay, so the first guideline that you can test your relation schema, okay, that each tuple in a relation should represent one entity or relationship instance, okay, and in terms of attributes of different entities, for instance, employee, department, project, should not be mixed in the same relation. We should have them separately. Information about or attributes that are needed for the employee will be put in employee relation. The information or attributes that are related to the department, they will be put on another relation. Location, department location, I will put that information in another relation, and so on. Okay, and only foreign keys should be used to refer to other entities. Okay, like we did here. I do have here foreign key, and this foreign key is referring to another entity, to another relation. Okay, like here, for instance. And we do have the same way here. I do have foreign key here. It is referring to this primary key, the number and the location, and so on. So these are the first entity. Okay, when we do have a first entity, we talk about an entity and relationship. They should be kept as part of, as much as possible. Here, when we talk about a relationship, here, those in a relationship between the different relations, it will be done through a foreign key. Should not include them within the same entity or mix up. We have, let's say I don't have here, we do have, yes, okay, imagine now here you do have this big entity which mix up the employee information with the department information. Okay, employee names, SN, birth date, address. Don't look at those arrows. We're going to talk about them later, Shababa. Just look at the entity itself. Okay, here we mixed up the employee and department information. If you can compare it to the previous one, okay, these are separated. It is clear, they are clear, and you're going to see some problem that will arise by having a mixture of information from different relations. Another guy, for instance, has made this relation, okay, in his design project. He just mixed up the employee information, employee and the project, okay, P number, hours, e-name, P-name, P-location. So it is a mixture of information, okay, that should not be done because it does violate the guideline number 1. Number 1, it says here, only within each tuple or within each relation, it should put only those attributes that applies to the individual tuples. We cannot mix up different from, we can put different entities, okay, different attributes of different entities within one big entity. So this is the first guideline, which is guideline 1. We mentioned at the beginning, okay, why we need to measure, how we can measure also the quality of your design is by reducing redundant information in tuples. Okay, when we talk about information or redundant information, that means you are wasting of storage, okay, because you do have repeated information. Okay, when we do have repeated information, that means we are wasting, we are taking space within our database, okay, which is not advisable. In some circumstances, you cannot have information. You cannot have, or you don't have enough space to store many information. So you need to save space. How we can do that? By eliminating redundancy. Okay, and also what redundancy will cause on top of wastage of storage, it will cause problems which are related to what is known as update anomalies. When we talk about updating, that means we can do, for instance, insertion without deletion or modifying. And anomalies that are things that are not, let's say, acceptable. Let's have an example here, for instance. Okay, consider you do have that employee project relation. Okay, and as we mentioned, we do have employee number, project number, employee name, project name, and number of hours. Now, in terms of update anomaly, let's imagine that you want to change the name of the project number P1. Okay, this project number P1 from, let's say, from billing to customer accounting. Okay, now what we will have here, imagine that you do have 100 employee who works for the same project. They do have the same project number, okay, which is one that was yes, for the project number of project name P1, it was project P1. Then you decided to changing to customer accounting. So what will happen? What you will need to do? Yes, guys?
Sorry again?
If I want, this is what I'm talking about, update anomaly. That means I want to change at the beginning the project number that was P1, okay? The name for that project number, which is the project name, corresponding to project number 1, was billing. And I wanted to change it to customer accounting. In this type of relation schema, okay, what you will have?
So I think this might be a mistake because the project number is not a string. It shouldn't be in this format, billing and customer accounting.
You didn't get my, just let me,
So, Doctor, you mean that you will need to update this tuple for each entity?
Barakallahu fik. We need to update that information for each existing entity. Okay, for each existing entity, let's say you do have, I do have, this is my relation, and these are my tuples. Okay, and imagine that you do have 100. Okay, and I'm not going to design them. Okay, and I'm not going to show all the attribute. Okay, but let's imagine that this is the project. Okay, this is project number. Okay, and this is project name. So we have here, for instance, project name. Okay, in this the safe space. Okay, this is my project space, and let's say these are name. Okay, employee name. It's an employee name. Okay, so let's say if you do have here, I do have an employee A. Here I do have an employee B, and I do have another employee C, and D, and whatever. Okay. Okay, and I do have here the same guy. This employee works for project number 10, and this employee works for project 10, and another employee here works for project 10. Okay, of course the project number corresponding to 10, we should have the same name. Okay, Shabab, that means let's say the project name is X here, and the project name here is X also, and I do have here project name is X also. Okay, what I need to do here now, if I want to change it from X to Y, what I will do? What I will have to do?
We need to query all projects with number 10.
Yes, good.
Then we update the name for each one.
Can you see now the problem? You have 100. You might miss within your database. I might have, for instance, number 100, the last, maybe. Let's consider that this is 100, the last one. Okay, or the 99 employee who was working for that project 10. Okay, and I did manage to change that X to Y. By that last one, okay, I forget to change it. Okay, so this is the problem that will arise from, which is known as update anomaly. Because why this happened? Because you mixed up the information of employee with the project. Okay, now if we go to the good design, for instance, when I do have employee, okay, I will have here, for instance, project number. Okay, and I will have another relation where in one relation, Shababa, look here, in one relation, let's consider this is a project relation, and this is employee relation. Okay, now here I do have, for instance, project number. Okay, and I do have, let's say here, project name. Now in this type of schema, where do I have to change the project name, Shabab? Where?
Only in the project relation.
Barakallah. Only on the project relation. Okay, let's say here, this is my project relation number. Project number, it is here, it is the same. If I wanted to change the project name, I will go to the project itself and change that project number corresponding to 10. I will change it from X to Y. I will change it only in one place, once. I don't have to go through all 100 employee and do the changes. Why? Because that foreign key, that relation between project number and automatically. Okay, I will change it only once here. I don't have to go through 100 employee because I didn't mix up. I didn't include in the employee relation project name because it is not related. That attribute, this attribute project name, is not related to the employee. It should not be put here like we did in this schema. In this schema, we mixed up employee name, project name, and project number in one big relation. This is not acceptable. And this is what will be caused. This is why when you do, because even here, as we mentioned here, we are wasting of the space, because we do have here, we are repeating. Okay, the same project name is repeated 100 times. Okay, which shouldn't be there. Okay, here it is just once. We have allocated one place, okay, in memory for that project number corresponding to 10. It is X, but I don't have to write it down and to allocate space for 100 place for just repeating project name. So I need only, of course, we need to repeat the project number, because it is needed to specify this employee works for this project number, but we didn't repeat the project name. If I want to know what project name corresponds to the project number 10, I will go to the project relation, search within the project number which one is 10, okay, and I will just get the project name. Okay, Shabab? Yes?
Doctor, but the concept as a whole, if I want to change an attribute in the project relation to customer sales, I do have to need to go over all the entities or tuples, right? Eventually.
Yeah, no, for the value. And here we're not talking about the value, Shabab. Okay, here we are talking the problem of mixing up attributes with different semantics within the same relation, which is not acceptable. And this is what I have shown you now. I have just shown you an example of such bad design. Okay, of course, if you have decided that this is a good design and I will change the value, then there is no problem to change the value. But the problem is when you mix up the information of different entities within one big big relation, this will cause you some update anomaly that are related to that because of that bad design. And what you have seen now, the insertion anomaly. So just an example of an insertion anomaly. Tomorrow, inshallah, we will inshallah make it more clear, inshallah, Shabab. Okay, guys?
Okay.
Okay, thank you very much.
Okay,
I will see
thank
you
you.
tomorrow, inshallah. Allah yaikum afiyah. Shukran.